Alrighty, so this is our last type of factoring that we're going to do algebraically. And this is kind of like this will work no matter what, right? So if you don't like doing GCF, difference of perfect squares, and then like traditional, the diamond factoring, this will always work. And I remember when I was in school, I would just run this almost all the time because it's just, it's like a hammer that can always be used no matter what, which is kind of cool. The issue is if, we're not looking at the regions right now, but if you plan on taking like the SATs or the ACTs or something like that, that requires some kind of factoring, this might be a little bit slow, and I think for that you'd have to memorize it. For geometry regions and stuff past algebra, you'll have this formula given to you, but it might just like take a little bit more time than if you knew how to factor the other ways. But let's jump to it. So first I'm just going to say, all right, so far we have seen GCF factoring, difference of perfect squares factoring, and diamond. Ooh, yikes, that last word was no good. Diamond factoring. And clearly you can see that my computer's having a little trouble keeping up on the document camera over here, but it's okay. Diamond factoring. So the last thing that we're going to see here is the quadratic formula. All right, quadratic formula. So, cool. Let's get to it. So, yeah, I just wrote down the 4 different types of factoring. And by the way, this is the order you should try it in, right? So if you're trying to factor something, look to see if there's a number or a variable you can divide out of everybody and just drag that in front of the parentheses, right? Next, if you have a difference of perfect squares, that means a perfect square being subtracted by another perfect square, then you do your difference of perfect squares, plus, minus, bada boom, the roots of them. Diamond factoring is when you look, that's kind of the traditional way, where you look for the third term, 2 numbers that multiply to that, and then the second term, those same 2 numbers should add to that second one, right? If all else fails and you can't figure it out no matter what, quadratic formula is there for you. So let's hop back into Word over here. This is our quadratic formula, right? So, and this is, what it's saying here. When you cannot factor quadratics, you can use completing the square. However, that only works, blah, 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 blah. When all else fails, use the quadratic formula, which is what I'm saying. It's on your reference table. SATs, ACTs, I think you have to memorize it. If you have to memorize it, well, before we get there, let's analyze it for a second, right? So, if you are given a function or an equation or an expression that you're asked to factor, it usually is going to have, unless there's some GCF to pull out of it, it's usually going to have an x squared term, an x term, and then a constant term. The a and the b in this case, and the c also, those are actual numbers, right? The a and the b are coefficients. C is going to be a constant. So, for example, let me just draw a quadratic formula over here. So maybe we have something like, I don't know, let's use the first example. Why not? Just so I can look at it. X squared, 2x minus 3. All right. So if I have something like x squared, is it plus 2x? Plus 2x minus 3. X squared plus 2x minus 3 equals 0. The first thing you need to be able to do is look at the 3 terms and then say, okay, a is going to be the coefficient in front of my first term. There's no coefficient there. It doesn't mean that a is 0. That means that a is really going to be 1. And then b is your second one, or the x term, right? If they're not in order, you have to look for the x squared, the x, and then the constant. My b term is going to be 2. The b, the coefficient, just 2. We're not worried about the x's, right? That's just telling me who's a, b, and c. And then finally, c is not just going to be 3, but it's a minus in front of it, so it's going to be a negative 3. So that is my a, b, and c. That's how you get it from there. Look for the x squared term. That's your a. The x term, the coefficient, is your b, and the constant is your c, which is kind of nice because it's constant. It's c, right? All right, let's keep going over here. Now, that's just for identifying a, b, and c, so you can plug a, b, and c into this beast of a formula. If you have a reference sheet, Great, right? You just write the formula out, plug in your A, B, and C, and you're good. You don't have a reference sheet. I like to do this I had it memorized to the Jack in the Box song. So the way I memorize it, in case you need it for the SATs, would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's just how I memorized it. If you do that like 3 or 4 times, you should never forget it again, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's try it out, right? So example number 1, we've got x squared plus 2x minus 3 equals 0. A, B, and C we've already labeled out. I'm going to rewrite the formula over here just so that, we have room over here to do the work. So it is x equals negative b plus or minus the square root. I'm running out of room. B squared minus 4ac all over 2a. Okay, this is our formula. Let me write this a little bit better. And now we can start plugging in to our formula. So we've got x equals, and then negative b is my first thing. So I'm going to say negative, because that negative is there. And instead of b, I know that b from this original quadratic equation was 2. So negative 2. Plus or minus we will talk about in a moment. I'm just going to leave it there. Plus or minus the square root, right? I'm just copying from over there. The square root of b squared. So I can either write 2 squared, or if you know it right away, you can just plug it in right away. So this is going to be 4 minus 4, and then AC I'm going to actually plug in. So A I'm going to put as a parentheses 1, C I'm going to put as a parentheses negative 3. Parentheses negative 3. Let's extend the roof over here, and then all over 2A. So it's going to be 2, and then parentheses 1. So here's me plugging it in. The orange is where I put in numbers. I guess I could have made this orange because I did plug in a b there and then I already squared it. Whatever. So let's get to it, right? Following PEMDAS, I'm going to look inside of groupings, right, or GEMDAS, because really this is a grouping. It's better than saying parentheses. And inside of this grouping, I'm going to follow again, right? So it's going to be, okay, well, I could do 4 minus 4, but before that, multiplication happens before addition and subtraction. So I'm going to do 4 times 1, still 4. 4 times negative 3 is going to be negative 12, but I'm going to take this as a negative 4. So I'm going to do negative 4 times negative 3. So when I rewrite this down here, x equals negative 2 plus or minus the square root of this 4 coming down. And there's going to be negative 4 times 1, who cares, right? Doesn't matter. Times negative 3, it'll be plus 12. And then on the bottom, I'm also going to do this group on the bottom here. 2 times 1 is just 2. Looking good so far. I'm going to keep scrolling down on the paper a little bit just to see how it goes. Inside of this grouping over here, I'm going to do, all right, x equals negative 2 plus or minus the square root of 16 all over 2. And that was just 4 plus 12 is 16. And now we're going to do, well, what's next? Parentheses, we already did all the different groupings, other than we should be doing the top grouping, right? And then exponents, multiply, divide, add, and subtract. Square root is technically an exponent thing, so that's going to go next. Square root of 16 is going to be 4. So I'm left with x equals negative 2, the square root of 16 is going to be changed to a plus or minus 4 over 2. And here we're getting to the plus or minus 4. Do not forget, the whole purpose of factoring is to find the roots of a quadratic. So a quadratic can be your smileys or your rainbows, and the roots or the solutions are the 2 places where it hits the x-axis. usually it's two places. Maybe if this smile was above, it's 0. Maybe it just barely taps, there's only 1. But this fact that it can be 2 at most and less than 2 otherwise is where this plus minus appears in the quadratic formula. So this plus minus just means I need to do it twice. I need to do it once as a plus, and I have to do it again once as a minus. That arrow looks kind of sad, but let's just do it. So I'm going to rewrite once as a plus. So this is going to be negative 2 plus 4 over 2. And then I'm going to write it once as a minus. So it'll be negative 2, instead of plus or minus, minus 4 all over 2. And from here, we just have to finish it up, right? So on the top here, negative 2 plus 4 is going to be equal to positive 2. Bring this 2 over. 2 over 2 is going to get me 1. That's one of my solutions. X is going to be equal to 1 as one of my solutions. And then here we do the second part. So negative 2 minus 4 is going to be negative 6 over 2. Negative 6 over 2 is going to be negative 3. Here are my two solutions. So at the end of this, I can say that x equals 1 or x equals negative 3. So this actually is kind of nice because in the other ones we got factors and then we found solutions. Here we get the solutions straight up because the quadratic formula starts as x equals. So here are solutions. Now, if they ask for factors, you just have to remember your factors and your solutions, they're just switched. So if I wanted factors, these are solutions. If I wanted factors, all I would do is just flip the signs. So it'd be x minus 1, x plus 3 equals 0, right? So that's what the original question we started with looks in its factored form. The solutions are just the opposite sign of your factored form. That is an introduction to the quadratic formula. I think I'm going to end the video here. Next video, we're going to do maybe 2 or 3 practice ones over here. Yeah, there we go.